All right, we're now going to talk about radio telescopes, because remember I was talking about how on the electromagnetic spectrum, the energy we get from space is absorbed mostly by our atmosphere, except in the visible part of the spectrum and in the radio part of the spectrum. Now, radio telescope, remember, radio waves and visible light rays, they're still electromagnetic waves. The only difference is the wavelength. Okay? They're still the same beast. So to do a radio telescope, the problem is, here's my radio telescope, is that you need to have a really big dish. Okay? Essentially, this is just like a mirror. But with radio waves, all you have to do is have metal, and the gaps between the holes in that has to be smaller than the wavelength, and it'll reflect it. So what happens is the radio waves coming in will like this, will hit here, and then they'll bounce and get focused up to the point up here, and then you have a radio receiver at the end. So it's just like this, where this is the focal point. Light rays come in, or radio waves come in, bounce, they focus to a point of radio waves here. And that works for all radio telescopes. Now, there are certain advantages to using radio astronomy instead of visible light. Remember when we were talking about black body radiation, though, they really study different things, so it's not really a competition. It's what you're studying, depends on what telescope you're using. If you study stars, like that's my specialty, is I study stars, I use optical telescopes because that's where they put out their light. Okay? But if you want to study cold gas in the universe and things like pulsars, they put out lots of radio waves. Then you use a radio telescope. Because remember, black body radiation, radio waves, means it has to be from objects that are very, very cold. Okay? Now, if you're getting things that are pumping out radio waves, like pulsars, then they're not cold, but they're actually putting out radio waves because of their magnetic field. All right, so the advantages to a radio telescope is you don't have to put a radio telescope on top of a mountain or in any special place, because the atmosphere doesn't affect radio waves at all. So they don't have to be on the top of a mountain. You don't have to worry about it. So weather doesn't affect them. As opposed to optical telescopes where you have to have a nice clear night. Now, I shouldn't say weather doesn't affect it. You can't use your radio telescope if you're in a thunderstorm. If there's lightning around, the lightning actually puts out radio waves and it messes the thing up. So a thunderstorm, no. If it's just cloudy though, radio telescopes work fine. They just see right through the clouds. As you know, when it's cloudy outside, you don't lose your radio signal. Your dish satellite doesn't all of a sudden not work when it's cloudy. The only thing that makes it not work is if you have a really heavy thunderstorm or something like that. Two, the nice advantages of the radio telescope, this is advantages, is the surfaces don't have to be as perfect. Because you're dealing with such longer wavelengths, a lot of the wavelengths are like this long. If you have a bump that's smaller than that, the wave won't even notice it. So as long as you're smooth to the wavelength that you're looking at, radio telescope, you don't have to be perfectly smooth like you do with a mirror for an optical telescope. And then number three, you could use them 24 hours a day. Because you don't have to wait for it to be night or daytime. Now you can't look close to the sun, it puts out a lot of radio waves, but you can use them in the daytime just fine. So they're used 24 hours, they're running all the time. One of the other things that radio telescopes currently have the advantage of, it's interferometry. Interferometry. Okay, pretty sure I spelled that right. This is a complicated way of saying what they do is if I have a telescope, here's my radio telescope, right here. But I make another radio telescope right here that's pointing and looking at the exact same thing at the same time. I can combine the signal of these two telescopes. So what happens is, light rays coming in hit that telescope slightly before this telescope. And remember, light is waves, right? And so if you combine them, if the waves are out of phase, they interfere with each other, which is where the word comes from. Because that interference pattern can be used to determine what you're looking at. And that's why they call it interferometry. The distance between the telescopes they call the baseline. Now the advantage to this is, with telescopes, the idea is you're trying to look at as small a detail as you can, right? What we call the resolution. If you have two telescopes connected together, you can make it, the resolution, the detail that you can see, just as good as if you had one really big telescope. So instead of building one super huge telescope, you can just connect them together and make it act like a really big telescope. And so then they started doing, well, we don't have to do two, we can connect a whole bunch of them together. And so you can connect a lot of them together, and they created what's called the VLA, and I'll show you pictures of that in a second, which is called the Very Large Array, which is in Socorro, New Mexico, and they connected to like 30 dishes altogether. And then they said, well, hey, we're not even limited to that, we can go beyond that. We can put satellite dishes all over the Earth and connect them all together, and they call that VLBI, which stands for Very Long Baseline Interferometry. And then you actually have a telescope that acts like it's a telescope the size of the Earth. So remember, what's critical is the angle or resolution you can see. For a normal telescope from the Earth, you can see to about 1 arcsecond. For the Hubble Space Telescope, you can see down to about 1/100th of an arcsecond because you're up in space. With VLBI, you can see resolutions down to about 1/1000th or 1/10,000th of an arcsecond. So fine details can be determined. And there's thoughts of even going beyond that. It's like, well, what if we put one on the moon and on the Earth and connect them? Or put one in space and just send it out, and then the baseline keeps getting longer all the time. So those are plans, they just haven't happened yet. But those are ideas of making very long baseline. So this is the largest steerable dish in the world, which means the whole dish can rotate and turn and move and can point to anywhere in the sky. This is in Green Bank, West Virginia. Now you're like, West Virginia, that would be a lousy place for an optical telescope, but it works just great for radio telescopes, and that's where the National Radio Observatory is, NRAO. And it's cool in some ways. Some people would really hate it because if you work or live anywhere around that, they allow no cell phones, because the cell phones actually mess it up. And they have these police that if you have a cell phone signal, they can go and they chase you down and say, you must turn that off. And if you're a visitor to go there, it'll say you must turn off your cell phone. And even some cars put out radio noise and stuff that gets in the way. So it's an interesting place. Now it's kind of off in the middle of these mountains here, and so you're just not really on the way to anywhere, so it kind of works as a good place to have your radio telescopes. This is a very large, as a matter of fact. This is 100 feet across. So this is really big. You can tell this is relative size. Humans are about this big. So this is way bigger than any optical telescope. And you notice that, look, you can see right through the clouds and everything here. As long as the mesh here, the holes between the mesh is small in the wavelengths, it works just fine. This is Arecibo in Puerto Rico. And this is the largest disk in the world. But notice the disk only shows straight up. Essentially what they did is they put this disk in a valley, and then all the light comes up to this receiver up here. Now you can actually look in different directions, because if the light comes in from this way, it's going to focus up over here. Well, you just move your receiver, and you see this receiver up here. This can be rotated around and moved to different positions, and so you can see to about 20 to 30 degrees from vertical. but mostly you have to be looking straight up. But this is a really powerful antenna. This would pick up your cell phone signal if you were on Saturn, close to 1 billion miles away. That's how powerful it is. Okay? So it works great. This is one of these telescopes that if another civilization halfway across the galaxy, 20,000 light years away, had a telescope like this, they could pick up our signals and we could pick up their signals. It's a very sensitive telescope. Okay? This was also in the movie GoldenEye, the James Bond movie, if you ever saw it. In their movie, they actually have it coming out of the water. It's not coming out of the water. It's in Puerto Rico. And it's also in the movie Contact, if you ever saw the movie Contact. This is where she starts out at. This is a picture of the top, where you can go here. This is a catwalk for the people to go across. And talk about you got to be really brave and not fear of heights to walk across this catwalk that's swinging up here across the valley floor, which is like 300 feet below you. And the dish that hangs down here in the valley, it's off the ground, and so plants and trees and stuff are growing underneath it all the time. And light comes through it. This is the VLA I talked about. The VLA, the Very Large Array in Socorro, New Mexico. And notice that all the dishes are pointed at the same object. So this is interferometry. And they can reconfigure the dishes. They can move them to different positions. There's actually train tracks going out here. And they can grab the dish and move it to different positions, depending on what they're looking at and what wavelength they want to look at. This is where Jodie Foster ended up in, if you saw the movie Contact. If you haven't, you should. It's a good movie. Here it is from the ground. You can see all the dishes are the same. They're all pointing the same direction. This has been remotely run for a long time.